Hi there. Thanks for having me. So as you're saying, I want to talk today about some of the lessons we've learned on the Chrome team as we move towards shipping these various AI APIs in our browser. So to be concrete, we're specifically working on these 7 APIs at the moment. All of them, except for the prompt API, are what we're calling high-level task APIs. They have API surfaces designed for specific tasks, and they mask the complexity of the underlying machine learning models from the web developer. The prompt API is an earlier stage proposal. It's currently only in web extensions. And so we're hopeful that this task-based approach can provide for many of the cases that web developers are asking for with less interop and compat risk, which we'll talk about shortly. As you can see from the links on the bottom, these are all at various levels of maturity within the web machine learning community group. For the first 5, we have full specifications. They're very close to complete. For the prompt API, we have a detailed explainer. And for our newest addition, the proofreader API, we have an explainer that's been proposed for adoption. So we've been excited and thankful for the WebMLCG for hosting us and for providing a space to collaborate on all these APIs. One thing that we noticed when we started on this effort is that the web platform already includes a number of task-based machine learning APIs. So to some extent, the web community has already been dealing with the challenges posed by exposing these sorts of capabilities. For example, there's no guarantee that the shape detection API will give the same results in different browsers or in different versions of the same browser. But developers seem to be happy using these APIs, several of them, anyway, when they're not prevented from building apps. Another way of looking at this space is that it's part of the general program to make the web a powerful development platform, and that one that exposes all the features of the underlying operating system. So like most operating systems come with various sensors or other capabilities, these days, operating systems often come with machine learning models. And so just like we want to work to expose those other OS capabilities to web apps, in Chrome at least, we want to expose these bundled ML models to web apps. And you can't always depend on the results in the same way, right? Just like the core part of these specifications for OS capabilities says something like measure the ambient light or send the user a notification and leaves the details as some kind of quality of implementation issue. It's the same sort of thing with these machine learning things. We've built a moderately successful platform, even though the core of these algorithms and specifications is something that's much harder to pin down. But I don't want to downplay the challenges that come with these sorts of APIs, even if it's just an extension of what we've seen before. The most significant challenge from our perspective is interoperability between browsers and compatibility across browser versions. Both of these essentially boil down to the same problem, which is how do we ensure web developers don't rely on very specific behavior, which might be different in other environments. So there are some measures that we can take, which I've listed up here, but it's still uncertain whether this will be enough. We have many developers in the AI space that are coming from building directly against server-side language model APIs, provided by cloud providers or model companies. And in those cases, they hard code a model version, and they have very specific workflows that are around parsing the output and so on. When we talk about these APIs with them, they're often cautious about whether such high-level task APIs can serve their needs, or whether a model that might that might change its version out from underneath them is tenable for them to build a product on top of. Another issue here is that the traditional tools that we've proven so successful at reaching interoperability with, such as the Web Platform Test Project, are not really suited for testing the core algorithms here, such as summarize or recognize this face or translate this text. I think there's room to do better. I think we could stand up some sort of parallel ecosystem of testing that uses a different style, more akin to machine learning evals. But I think this would be a large effort, and it's more in the expertise of machine learning experts than browser engineers. Finally, there's kind of a novel problem here, especially with the APIs based on large language models, which says that their device memory requirements might give more uneven coverage than we've ever seen before. APIs that only work on mobile or only work on desktop or even only on certain operating systems, that's something developers have dealt with. But APIs that only work on devices with enough GPU memory is not something they've really had to deal with before. So it's going to be hard to know whether that's something that developers are prepared for. Another classic set of concerns for these APIs, like others that expose platform capabilities, is privacy and security. So for Chrome, we've recently completed our initial round of the privacy and security reviews of these APIs, and we came up with an audit of the potential problems and the proposed solutions. You can see here I've linked to a pull request that kind of adds to the specification all of our thinking on privacy and security and issues that have come up. The most concrete concern is around how we expect to implement these APIs by sharing a language model across all sites, and that can be used for cross-site tracking, which is a privacy issue. But there are other concerns, such as ensuring that the models don't train on user input, that users' resources, such as disk space and GPU memory, are not abused, and that websites can feel confident that the data they run through the models will stay on device. Overall, without getting into the details in this short talk, I feel cautiously optimistic that the privacy and security concerns for AI models are similar to the sort of challenges that we've seen before with other APIs. It will require careful monitoring, careful design, but there's nothing fundamentally different about AI in this regard, in my opinion. But the final challenge I want to mention is that this is a fast-evolving space, and fast-evolving spaces have historically not been the web's strong suit. We got a recent comment in a WebML community group meeting from a web developer that the prompt API feels like it's about a year behind the state of the art in server-hosted model APIs. We're starting with just text, and then in the recent months, we're adding images and video, but the cutting-edge models that they can get access to from cloud providers, they've moved on to real-time audio-video exchange and agentic tool use. Can the web even keep up? Even just on the API surface level, the best practices and patterns are evolving quickly. Server-side AI companies have tons of different APIs. There's been some small degree of consolidation around OpenAI compatible JSON formats, but there's really no guiding standards body where all the providers sit down and hash out what a good API surface looks like. And unfortunately, I don't think the incentives are aligned for those companies to do so. They're too busy shipping and iterating to stop and design a backwards compatible forever platform of the sort that we have on the web. There is some incentive for open source developers to create wrapper libraries that unify different APIs. Examples include things like transformers.js, which, if I understand correctly, is the foundation of Mozilla's current experiments, or Vercel's AI SDK. We can do our best to draw on the expertise of these communities and the design work that they've done. Ideally, we would engage them more directly at the W3C. I will say that one path we could take for this whole space and this whole challenge is to use the standard web platform slow follower role that we've gotten used to. We wait a few years for things to settle down. We come up with the best lowest common denominator API that paves all the cow paths. But I'm not sure that this is a workable strategy in the midst of the singularity. So to sum up what we've talked about today, I think the good news is that many of the challenges here are familiar. Web standards organizations already deal with exposing non-deterministic device capabilities. It's hard, but we have a playbook that's worked reasonably well, and it will just get stress tested in a new and exciting domain. I think we should all watch how our attempt at Chrome to focus on these high-level task APIs goes, instead of exposing the capabilities super directly. If web developers are excited to use these, then I think we're in good shape, and much of our playbook is intact. And I'm personally hopeful that this will give an even broader audience than the hardcore developers who are knee-deep in cloud APIs and model runtimes. I do think there's an exciting possibility for a new interop testing paradigm as a sibling to or as part of the Web Platform Test project that draws on the machine learning field's expertise. But I think that would be a challenge to stand up. And then I think we should try and do our best to get more ML API experts in the room. We have plenty of ML implementer expertise in the W3C. We work with several of them in the community group and elsewhere. But I'm talking about the people who are currently designing the HTTP APIs at the big labs, or the big open source developers who are working on these wrapper libraries. Bridging the cultural gap between web standards and those developers will be a challenge, but we've done similar efforts before to bring in outside expertise. But yeah, finally, the problem I don't really have an answer for is the usual one. Don't let the web get left behind. We lost mobile, and AI is an even faster moving space. So we should do what we can to do better this time. Thank you. That's it for me.